All right, guys, welcome to mystery number one. First of all, though, I want to make sure that I wish R.K. Malcolm happy birthday today because it is April 26th and his birthday was yesterday. And we just wish R.K. a nice happy birthday. Today's mystery has to do with the cascade between the hypothalamus, pituitary gland, and thyroid gland. The hypothalamus, when necessary, will release a hormone called thyroid releasing hormone. That stimulates the pituitary gland to release TSH, which is thyroid stimulating hormone, and that will stimulate the thyroid to release thyroxine, which is also known as T3 or T4. Okay, and this will speed up your metabolism and generally make everything work faster in your body. All right, so that's how these things work. Now, what we're going to do is we're going to use a mystery situation where basically you guys have to tell me, probably through email, which hormone was given to each rat in this mystery, okay? And the hormones will either be thyroid releasing hormone, thyroid stimulating hormone, and thyroxine. You're gonna do this by basically comparing certain rats to what a normal rat, there's a normal rat, this is our control rat. And so normal rats typically weigh 285 grams. Their pituitary glands are about 12 milligrams. Their thyroid gland is 250 milligrams. Their thymus gland, okay, usually is about 200 milligrams. The adrenal glands weigh 40, and the testes weigh 2,900 milligrams in males anyway. So this is a normal rat. Now what you guys are going to do is you're going to be given autopsies of 3 rats, okay? Here are the 3 rats. There's rat A, there's rat B, and of course there's rat C somewhere around here on my papers. Yeah. So here's rat C. Now, all 3 rats ended up dying looking like this. Okay? All 3 rats lost tons of weight. Okay? It's a very catabolic pathway, and so basically when you have lots of thyroxine in your body, you lose weight, you burn calories really fast. Okay? Now, your job is to look at these 3 autopsies on rat A, rat B, and rat C, okay, to compare them back to control and tell me which hormone they were given, whether it was thyroid releasing hormone, thyroid stimulating hormone, or thyroid hormone itself, okay? Notice in all 3 cases they lost weight, okay, but in all 3 cases different things happened to the pituitary gland and thyroid gland. I'm going to give you a little hint, okay? Even though I'm including the adrenal gland and the thymus gland on the data and the testes, this pathway has nothing to do with the thymus, adrenal, or testes. So you can just disregard those numbers. They basically just stay the same, all right? They might differ a little bit just because A, B, and C are not the same individual, but this pathway only affects the thyroid and the pituitary gland. Notice in person A, or in mouse A, basically, or rat A, his pituitary shrank, okay? And his thyroid gland, normally 250 milligrams, dropped down to 140 milligrams, okay? And in rat B, the pituitary grew from 12 to 16, so that's an increase. And its thyroid gland also grew from a normal 250 milligrams to 300 milligrams. That's quite an increase, okay? And the same thyroid increase we see in C, meaning the thyroid grew, but the pituitary shrank quite a bit, 4 milligrams, all right? So here's how you learn how to solve these problems, okay? Number 1, okay, you always compare back to the normal. So I'm not going to compare rat A and rat B. I'm not going to compare rat A and rat C. I'm always going to compare rat A to the control, to the normal rat, okay, to the rat whose numbers were right here. And you might want to pause and write those down. Now, that's step 1, okay? Step 2, okay, after looking at the overall weight, because we're in a catabolic cascade and they all lose weight, okay? First, remember that differences between glands have to be greater than 10%. So if you see something like 9 to 12, okay, that's a 25% difference. So that's significant. But if you see a difference between like 2,900 and 2,850, that's less than 3%. That's not significant. Ignore that. Okay? Now you need to look at the pathway again. Hopefully you've written the pathway down. If not, go back and do that. Okay? Releasing hormones will always increase the size of the pituitary gland and increase the size of the main gland. It will cause what we know as hypertrophy in both glands. Okay? So if you see, compared to the control, that both the pituitary grew and the thyroid gland grew, then it is definitely thyroid releasing hormone. Okay? All right. Fourth thing, if that didn't happen, okay, stimulating hormones will basically cause the pituitary to shrink and the main gland to increase in size. So it causes pituitary atrophy and main gland hypertrophy, meaning that if we gave a rat, excuse me, let my hands work here, TSH will feed back and shrink the pituitary, but it will grow the thyroid gland. It will make it grow. All right? And lastly, if you don't see that happening, okay, look at the thyroid and look at the pituitary. If they both shrink or experience what we know as atrophy, then thyroxine is the culprit. Again, okay? So we're looking at rats A, B, and C. We're looking at their data. Look at those numbers, okay? And compare them to the control data, okay? And then come up with your answers. That's mystery number 1, worth 15 points.